Okay, go ahead and take a look at this review for the test tomorrow. Um, so the first few problems, 1 through 7, we are simplifying, no decimals, assume all variables are positive. Right, so these are just simplifying radicals. All right, so let's take a look at the first one. Cubed root negative 216. Okay, so we would split 216 into factors. Okay, so I know that 216 can be broken down into 36 times 6. 6 breaks down into 3 times 2. 36 breaks up into 6 times 6. And both those 6's break up into 3 times 2 and 3 times 2. Now, if you had already realized that we're looking for a cubed root, so we're looking for 3 numbers that multiply together that are the same, and you already realized that 6 multiplies together 3 times to give us 216, then you don't need to break it up into 3's and 2's, right? You can just do it as it is there. All right, so we have 3 times 3 times 3, because there's 3 3's, and we have 2 times 2 times 2. So the index of 3 tells us that we need 3 of the same thing to come to the outside. So here we need 3 3's, so that brings a 3 to the outside. So a 3 comes to the outside, and then I also have 3 2's. Those are gone. So 3 2's brings a 2 to the outside, and everything's gone. Now, what we have here is 6, but it's important to keep in mind that at the beginning we were taking the cubed root of a negative number, so this should be a negative 6 that we're bringing to the outside, okay, because it's a negative 216, which means cubed root has to be negative, okay, because if we multiply negative 6 together 3 times, then it will give us negative 216. So the cubed root of negative 216 is negative 6. Number 2, we have the fourth root of 324. Okay, so we need to simplify this. We're looking for groups of 4. So I'm going to split up 324. I'm probably going to need a calculator to do this because I don't really know what multiplies to give me 324. So I will just check. I know that 2 multiplies 162 times. And then 162. That's 2 times 81. 81 is 9 times 9. And each of those break up into 3 times 3. Okay, so I can rewrite this as the fourth root of 3 times 3 times 3 times 3 times 2 times 2. Okay, so since the index is 4, we have an index of 4. I'm looking for a group of 4. So there's 4 3's that I can bring to the outside. So I'll bring 3 to the outside. Nothing else comes to the outside, so under the radical I still have 2 times 2. Okay, because only these 3's came to the outside. So this reduces to 3 fourth root of 4, or 3 times the fourth root of 4. And that would be the simplified version of the radical fourth root of 324. Number 3, fifth root of 486, a to the ninth, b squared. Alright, so the first thing I'm going to want to do is break up that 486. And once again, I don't really know what 486 breaks up into, so I am going to have to use a calculator here. It's even, so I know it divides by 2. So that's 2 times 243. 243, I'm not really sure what that's divisible by. It's not divisible by 2, but it is divisible by 3. Okay, 3 goes into it 81 times. 81 breaks up into 9 times 9, and each of those break up into 3 times 3. Okay, so I can rewrite this as the fifth root of 2 times 3 times 3 times 3. There's 5 3's here. So 5 3's. And then a to the 9th, that's 9 a's. 3, 4, 5, 6, 7, 8, 9. And then b squared, that's 2 b's. Okay, so I've got everything broken up. Now I'm going to start taking out groups of 5. Okay, so groups of size 5. So there's 3 5's here. So the first thing I can take out, whoops, would be like this. The first thing I can take out is a 3. 1, 2, 3, 4, 5. There's 5 a's here. So next I can take out an a. And that's it. Okay, that's all that's coming to the outside. So I still have the fifth root. And I still have some stuff under here. I still have a 2. I still have 4 a's. So 1, 2, 3, 4. And I still have 2 b's. Put it all together, this becomes 3a, fifth root, 2a to the 4th, b squared. And that's the simplified version for number 3, simplified form. Number 4, okay, so this one's a little bit weird. So I wouldn't be surprised if this one didn't make a whole lot of sense. So let's kind of look at it. And the reason, you have to remember what this exponent of 6 means. Okay, it means that it's multiplied together 6 times. So it's x plus 5 times x plus 5 6 times. So 3, 4, 5, 6. Okay, that's 6 times it's been multiplied together. Well, the index is 3. So I'm looking for groups of 3 of the same thing multiplied together. And we see that there's actually 3 of them right here. So that means I can bring out an x plus 5. Okay, because that's 3x plus 5's multiplied together. And then there's another one I can bring out as well. I can bring out another x plus 5. And then there's nothing left under the radical. Okay, this radical is gone. So I can say that then I can put this back together and I can say that this simplifies to x plus 5 squared. Okay, because 2 of these multiplied together would just be x plus 5 squared. So that would be the simplified version of number 4. Number 5. And yeah, these are kind of tough ones. So it's okay if you have to reference this to figure this out. We have number 5, we have the fifth root of negative 32 over 243. Now, a thing to remember with this one is that you can split this up. You can split the radical into the numerator and into the denominator. And then you can simplify each of them separately. You simplify the numerator and you simplify the denominator. Okay, so let's start with the numerator. That's 2 times 16. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. So 5 2's multiplied together. That should kind of give you an idea of what the fifth root of negative 32 is, because it's 5 2's multiplied together. And then 243, fifth root of 243, I think we just did this one. Yeah, so this is 3 times 81. 81 is 9 times 9. And each of these 9's split into 3 times 3. And then those don't split up anymore, so we can circle those 3's. So that's 5 3's multiplied together. 1, 2, 3, 4, 5. And remember, since this is a negative 32, then whatever this is going to be negative. Okay, so I'll just bring that negative sign to the outside here. Okay, you'll notice that I didn't put it on the inside. I'm just going to bring it to the outside. Okay, so I got my negative sign. Now, 1, 2, 3, 4, so 5 2's come to the outside. So the numerator is negative 2. And in the denominator, I got 5 3's, those 5 3's to come outside. So that's 3 on the bottom. So that just simplifies to negative 2/3. Okay, because the fifth root of negative 32 is negative 2, and the fifth root of 243 is 3, because that's 5 3's multiplied together, and that's 5 2's multiplied together. All right, number 6. Now this is an addition problem. Whoops, that's not. This is an addition problem, so this is 3 times root 20 plus 4 times root 5 minus 10 times root 45. Okay, now if you remember, the way that we have to add these and subtract these is we first need to make sure that they have a common radical. So they need to simplify. We need to simplify the radicals essentially, and these are all square roots. So we'll start by simplifying 3 square root 20. So 20 breaks up into 5 times 4, and 4 breaks up into 2 times 2. So this is 3 square root of 2 times 2 times 5 plus 4 square root of 5, okay, because 5 doesn't break up, so we don't have to worry about that. And then 45, so this is minus 10 times square root of 45. 45 is 5 times 9, and 9 is 3 times 3. So that's 3 times 3 times 5. And then we can start pulling stuff out. So it's 2 2's, so I can bring a 2 out because this is a square root. So that's 3 times 2 times square root of 5 plus 4 square root of 5 minus 10 times, I can bring out 2 3's, so times 3, and what I have left under the radical is a 5. Okay, so this is 3 times 2, so that's 6 square root of 5 plus 4 square root of 5 minus 30, because 10 times 3, 30 square root of 5. Okay, now that I have them all the same, they all are square root of 5. Square root of 5, square root of 5, and square root of 5. I can combine them into a single square root of 5 by adding the coefficients. So 6 plus 4 is 10. So 6 plus 4 is 10. Minus 30 is negative 20. So this is negative 20 square root of 5. and that's what we get when we add and subtract these. Now number 7 is multiplication. So this is the fourth root of x cubed times the fourth root of 4x to the fifth. And now that I think about it, I don't think we had any multiplication and division problems in the notes. So I am going to take these ones off the test if there's any in there. Okay, I'm making this on Wednesday night, so I will take these off, or sorry, Tuesday night. I will take these off the test, but I am going to show them to you just in case, but if there's any on the test, I am going to take them out. When we have multiplication, and they have the same index like this, so fourth root, we can just combine them under the radical. So this is x cubed times 4x to the fifth. And then I can just split them up. So this is, well, I'll tell you what, I'll do it like this. I'll do 4x to the fifth times x cubed, because that way when I split them up, all the x's will be next to each other. So 4 breaks up into 2 times 2. That's 2 times 2, then 5 x's, 3, 4, 5, and then 3 more x's, 2, 3. So in total I have 8 x's. Now, the index here is 4 because it's a fourth root. So I'm taking out groups of size 4. So there's one group of size 4, so I can bring out an x. And there's another group of size 4, so I can bring out another x. And then under the radical, I still have the fourth root, 2 times 2. Okay, put this back together and I will have my answer. So x times x is x squared. And then the fourth root of 2 times 2, that's 4. So my answer is x squared, fourth root of 4 for number 7. Number 8, now we're only seeing this one. This was kind of like one of the ones we had in our notes and in our homework. This is just about plugging in and using a calculator to evaluate this. Okay, so you will have to use the calculator for this. A formula that the police used for finding speed S in miles per hour that a car was going from the length L in feet of a skid mark is S equals 2 times the square root of 5L. Now there's two things we're going to want to do with this. We're going to want to use this to figure out the length and then also use this to figure out the speed. So one of them is just plugging in and one of them is solving. So letter A says if a car had a skid mark of 100 feet, so that's the length, what was the speed? Okay, so in this case we're looking for S, the speed. So we're going to plug this into the length. So this is 2 times the square root of 5 times 150. Okay, because 5L is 5 times 150. So that's 2 times the square root of, let's see what that is, 5 times 150 is 750. All right, so all I have to do here, it says round to the nearest whole number. All I have to do here is use a calculator to calculate this. 2 times the square root of 750. Okay, so let's do that. Let's get out the calculator. So I'm going to take the square root, so I'm going to do 750, and I'm going to take the square root of it, 27.3, and then I'm going to multiply it by, what's the equation? Multiply it by 2. All right, so it comes to about 54.77 or 55. Okay, so I'll say that the speed here, 55 miles per hour. So if the skid mark is 150 feet, then the speed was 55 miles per hour. Now for our next portion, about how far will the car travel if it skids from 70 miles per hour? So our equation S is equal to 2 times the square root of 5L. This time they give us the speed. So we have to plug that in and then solve for the length. Okay, so they give us the speed, 70, is equal to 2 times the square root of 5 times the length. Okay, so this will be solving this equation for L. So we'll divide by 2. So 35 equals square root of 5L. And then you solve this like you would a radical equation, okay? The index is 2, so to get rid of the radical, we raise both sides to the power of 2. Okay, that will cancel out the radical on the right side, and then on the left side, we just have to put that in a calculator, 35 squared, which is 1225. And then we divide by 5 to get the L by itself. And that tells us that the length is 1225 divided by 5, which is 245. Okay, so the skid mark here would be 245, I guess, feet. Yeah, feet. Oh yeah, it says it right there. 245 feet. Okay, so when you're given the length for this equation, you just have to plug it in and calculate. But when you're given the speed for this equation, you do have to actually solve it. Okay, so it all depends on which variable you're given. Are you given the speed or are you given the length? For numbers 9 and 10, write in radical form. Okay, so this is changing from exponent form to radical form. So remember the denominator of the fraction, so the exponent is 3 over 5. The denominator becomes the radical, and then the numerator just stays the exponent. Okay, so this would be the 5th root of 7 cubed. For this one, well, 1/5, that's the 5th root of 5x cubed. Okay, the denominator becomes the index, so the 5 becomes the index, and then the 1 is the exponent, and you don't really have to put that. Okay, you can put that, but you don't have to. Numbers 11 and 12 write in exponential form. Okay, so for exponential form, we just need to make it have a fraction for the exponent. Okay, so this would be 3 to the denominator would be the index. The index is 4, so the denominator would be 4. And then the numerator would be the exponent, but we don't see an exponent here, so it's just 1. Okay, it's an invisible 1 for the exponent. So 3 to the 1/4 power. Number 12, A, the denominator will be the index, so the index is 5, so the denominator is 5. And then the exponent is 3, A cubed, so this is A to the 3/5 power. That's exponential form. So 13 and 14 we're simplifying. So it says simplify x to the 2/11 cubed. Okay. So to do this, we just multiply, okay? Because remember the power property says we just multiply. So this would be like 2 over 11 times 3 over 1, which would be x to the 6 over 11, okay? Because 2 times 3 is 6. Okay, this is called power of a power, and when you have power of a power, you just have to multiply the exponents. So I would multiply 2 over 11 times 3 over 1, which is 6 over 11. So that would be the simplified version. For number 14, if I want to combine these, this is division, so I have to use the quotient property, which says that to combine these into a single x, I need to subtract the exponents. So 5 over 6 minus 1 over 6, which of course is 4 over 6. And you do want to reduce the fraction because 4 over 6 can reduce. It reduces to 2/3. So we would say that this is x to the 2/3 power. That's what this simplifies to. Now number 15, it says here to simplify, but we're supposed to evaluate. We're supposed to evaluate without a decimal. Okay, so that means no plugging it into the calculator, we just need to evaluate it. So there's a couple of steps to this one. First, we are not allowed to have a negative exponent. So to make it a positive exponent, we'll put it in the denominator. So this is 64 to the 2/3 power. And let me take this to a blank page so I have some room to work with. Okay, so this is how we fix it so that there is not a negative exponent. To evaluate it, we need to turn it into a radical. Okay, so the index would be 3, so this is the cubed root of 64. And then when we're evaluating it, we don't want to put the square on the inside. We actually want to do the square afterwards. We're going to put it on the outside. Okay, because that's going to make it easier because we can now evaluate the cubed root of 64 and then we can square it afterwards. Now, hopefully at this point, we know we're trying to break this into a number that multiplies together 3 times. Okay, so 64 breaks up into 2 times 32. 32 breaks up into 2 times 16. 16 breaks up into 2 times 8. 8 breaks up into 2 times 4. And 4 breaks up into 2 times 2. Okay, so 64 breaks up into 1, 2, 3, 4, 5, 6 twos. So I'm going to simplify that over here. Cubed root of 64. That's the cubed root of 2 times 2 times 2 times 2 times 2 times 2. So I can bring out a group of 3 2's, so I can bring out a 2, and I can bring out a group another 2's, so I can bring out another 2. So the cubed root of 64 is 4. And that's because 4 times 4 times 4 is 64. So this becomes 1 over 4 to the second power. Okay, because the cubed root of 64 is just 4. And 4 to the second power is just 16. So this is 1 over 16. And then numbers 16 and 17, these are solving radical equations. So we have 12 plus the square root of 2x minus 1 equals 4. So the first step here is to get the radical by itself. So to do that, I need to get rid of the 12. So I got the square root of 2x minus 1 equals negative 8. And now, to get rid of the radical, I raise both sides to the power of the index. The index is 2 because it's the square root. So I'll raise both to the power of 2. On the left side, all that does is cancel out the radical, and I have 2x minus 1. On the right side, negative 8 squared is 64. And then I can keep solving this. Add 1. So 2x equals 65. Divide by 2. So x equals 65 over 2. Now we do need to check this to make sure that it works, because it is possible that this doesn't work. So 12 plus the square root of 2 times 65 over 2 minus 1 equals 4. So this is 12 plus the square root. All right, so these 2's cancel. 2 multiplied and 2 divided cancel, so we have 65 minus 1. So this is 12 plus the square root of 64 equals 4. Square root of 64 is 8, so 12 plus 8 equals 4. 20 equals 4. That's actually a problem, okay? That doesn't work. So this has no solution, because when we check the solution that we get, which was 65 over 2, it doesn't actually work in the equation. Okay, for number 16, it doesn't actually work in the equation. So when we check it, that's a problem. All right, so it's got no solution. Number 17, 4 times the cubed root, 2x plus 11, minus 2 equals 10. Okay, the first thing, get this by itself. So there's 2 things over there that need to go away. We need to get rid of the 2. So we'll add it. 4 times the cubed root of 2x plus 11 equals 12. And then we also need to get rid of the 4. Okay, that 4 is being multiplied, so to get rid of that, we will divide. So that gives us the cubed root of 2x plus 11 equals 3. Okay, now the radical's by itself, so we can move on to getting rid of the radical, which means raising both sides to the power of the index, and the index is 3. So that's going to cancel out the radical on the left-hand side. So on the left side, we have 2x plus 11, and on the right side, we have 3 to the third power, which is 27. And now we can solve this for x. So minus 11, 2x equals 16. Divide by 2, x is equal to 8. All right, now keep in mind we got to check this, okay? So let me take this and let me check it by plugging in 8. Erase some of this. Okay, so I'm going to check. I'm going to plug in 8. So I got 4 times the cubed root of 2x, so 2 times 8 plus 11 minus 2 equals 10. Okay, so that's 4 times the cubed root of 16 plus 11. minus 2 equals 10. That's 4 times the cubed root of 27 minus 2 equals 10. Cubed root of 27 is 3, because 3 times 3 times 3 is 27, so that's 4 times 3 minus 2 equals 10. 4 times 3 is 12, so 12 minus 2 equals 10. 10 is equal to 10, so our solution here works. Okay, we get 10 is equal to 10, which makes sense. So our solution, x is equal to 8, works for this problem. All right, and looks like that's all of it.